In this lesson, we are going to solve simple exponential equations as well as some simple radical equations. Now, we've done this before if this looks familiar, but it ties in with the current unit, so we're going to hit it again. But if you're feeling like this is easy, it's because, yes, we've learned how to do this in previous units. So in number one, your first move is to get the variable by itself. So of course we will subtract 15 from both sides. So that's going to leave x to the 2/3 power, and that's going to equal 9. Now here's the fun part. If we want to get rid of this fractional exponent, we are going to raise both sides of the equation to the reciprocal power. Alright, so basically on the left side of the equation we're going to raise this to the 3/2 power, and on the right side we're also going to raise this to the 3/2 power. Okay, when you raise a power to a power you multiply, but if I multiply reciprocals then all of these will cancel out. So that is going to leave us with just plain old ordinary x. Now, if I want to do 9 to the 3/2 power, then it's easy to think about this in terms of a power and a root. So 3 is the power, 2 is the root. In other words, this is the same thing as the square root of 9. There's your 2. And then raise that to the 3rd power. You can do this in your head, yes? The square root of 9 is 3. And then, so that's 3 to the 3rd power, which is 27. So x is equal to 27. If you didn't remember 3 to the 3rd power, you could use the chart here. 3 to the 3rd power is 27. Okay, now, for these types of problems that involve radicals and such, it's important that we check our answer. So let's plug this back in and make sure that it actually works. I think I'll do that in green. Well, I don't like that color green. I'll use this color green. So if I put in 27, so this is my check. So that would make 27 to the 2/3 power plus 15 is equal to 24. So it's important just to simplify. We're not going to solve. We're not going to subtract 15 from both sides or anything like that. Everything is going to stay where it is. But if I want to do 27 to the 2/3 power, that's power over root. The root is 3, so we are talking about the cube root of 27. And then the 2 is the power, so that would be squared. And then plus 15, and see if that equals 24. Of course, the cube root of 27 is 3, so that leaves us with 3 squared plus 15. 3 squared is 9, so that's 9 plus 15. Now 9 plus 15 is 24. So 24 does equal 24, so it checks out. It's important to check your answers, because every now and then, even though you didn't make any mistakes, your solution, quote unquote, won't actually work. On number 2, the big mistake here is to think that you can distribute. Oh no, you cannot distribute the 3. Why? Because there's an exponent, and when we're doing the order of operations, exponents come before multiplication. So unless you're prepared to do something with this exponent, you can't multiply. So instead, what you want to do is divide both sides of the equation by 3. So I'm going to divide by 3 on the left and the right. That way these 3's will cancel out. And so that's going to leave me with x plus 1 to the 4/3 power is equal to 16. Alright, 48 divided by 3 is 16. Now, how will I get rid of this fractional power? That's right, I'm going to use the reciprocal power to both sides of the equation. Okay, so I'm going to raise the left side of the equation to the 3/4 power, Okay, so I'm going to do the 3/4 power, and I'm going to do the right side of the equation to the 3/4 power. Now over here, when you raise a power to a power, you're just multiplying, and these all cancel out. So that's going to leave me with x plus 1 equals. Now over here, 3/4. 3 is the power, 4 is the root. That means we are dealing with the 4th root of 16. That's the root. 3 is the power, so all that's to the 3rd power. Okay, so that's x plus 1. Now let's see, what's the 4th root of 16? Alright, I have this memorized, but you might not. 4th root, so I look at this column. There's my 16. Boom, it's 2. So the 4th root of 16 is 2. That means I have 2 in there. 2 to the 3rd power. Okay, 2 to the 3rd power is 8. And then I subtract 1 from both sides. So that gives me x equals 7. So that's probably the answer. But we should check our answer. Okay, so I'm going to check by plugging 7 in for x. So that makes this 3 times 7 plus 1 to the 4/3 power is equal to 48. So that's 3 times 8 to the 4/3 power is equal to 48. Power over root. So this is the 3rd root then. So that means I'll have the cube root of 8, and then the 4 is the power, so 4th power. The cube root of 8 is 2. So that means 2 to the 4th power. Okay, exponents come before multiplication. So 2 to the 4th power, whoops, why'd I put 16? Y'all should have told me. Say, hold up, Mr. Helpful, not hurtful. That's a 48. 2 to the 4th power is 16. That's probably where I got the 16 from. And guess what? 3 times 16 is 48. So 48 equals 48. So it checks out. So x equals 7 is in fact the answer to number 2. Number 3. Got to get this radical part by itself. So let's add 13 to both sides. So that's going to leave 4th root of 2x equals, alright, negative 9 plus 13, that's 4. Okay, now if I want to get rid of 4th root, I need to do the 4th power to cancel that out. So I'm going to do the 4th power to both sides. Alright, 4th root, 4th power, those cancel each other out. So that's going to give me 2x. 4 to the 4th power, is that 256? I'm not sure. So let's see, 4 to the 4th power is 256. Okay, I've done this enough times, they're starting to stick. 256. Okay, so of course now I will divide by 2 on both sides. So x is equal to 128, and that is probably the answer. But once again, we will check our answer. We will always check our answer. Okay, so I'm going to put in 128. So that would look like this. I'll have the 4th root of 2 times 128. And then minus 13 is equal to negative 9. Now again, we're not allowed to add 13 to both sides or anything like that. We have to just simplify and just stay on one side of the equation at a time. So 2 times 128, alright, you don't have to take my word for it. Alright, 2 times 128. All right, that's 256. So that'll give us the fourth root of 256 minus 13 is equal to -9. Now, the fourth root of 256, all right, let's consult our table. All right, fourth root, so we'll look in this column. There's the 256, so the root is 4. Whoops, wrong action. All right, so this is simply going to be 4. So that's 4 minus 13. And of course, 4 minus 13 is -9. So there you go. -9 equals -9. It does check out. So x equals 128 is the answer. If ever the check doesn't work, then we'll say no solution if this is the only solution. Alright, number 4, we need to get this radical by itself, so we will subtract 10 from both sides. So that is going to leave us with the square root of 6x minus 5 equals -7. Whoa! Stop right there, alright? Right now, I know this is going to be no solution, and I really won't go any further. Alright, I won't just mechanically go through the process, because I have the square root, and then I have that equal to a negative number. That can't happen. You know, if I take the square root of 49, for example, that's going to equal +7. But if I try to do the square root of, say, -49, that would be 7i, not -7. So there's nothing I can take the square root of. That's weird. There's nothing I can take the square root of that's going to give me a negative number. Okay, it's impossible. So it's no solution. Alright, and that's what you should do. Just stop and put no solution. Now, let's say if somehow you didn't see this glaring stop sign, and you just proceeded with the process. Then what would have happened would have been this. You would have had to square both sides to cancel out the radical, and that would have given you 6x minus 5 is equal to +49. Oh, I forgot to put the little 2 there. Yep, that would have made +49. And then if you just blindly went through the process, so add 5 to both sides, and that would give you, wait, I wanted to change colors. And that would give you 6x is equal to 54. And then if you divided both sides by 6, okay, so that's going to give you x equals 9. So you might have thought that 9 was the answer. But if you plug 9 back in, if you do the check, then you'll find that it won't work. Okay, because this would be the square root of 6 times 9 minus 5 plus 10, and that's supposed to equal 3. But that's the square root of 54 minus 5 plus 10, and that's supposed to equal 3. But this is the square root of 49 plus 10, but that's 7 plus 10. And so that's 17. Okay, and 17 does not equal 3. So either way you do it, no solution. But I urge you just to stop as soon as you see a square root equal to a negative. Now, to be clear, if this was cube root, that would be okay. A cube root can equal a negative. An odd root can be negative, just not an even root like 2 or 4 or 6. Okay, I'm going to go ahead and stop this video here at 15 minutes. And we will continue. Part 2, alright, the next video, we'll have plenty of more examples with some interesting things happening, some quadratics. So we'll check that out, and I'll see you on the next video.